to have a look at a fire flow, so I'll have a quick look at a fire flow. And then SCADA Connect Simulator, which is one of the newer features of both water and SewerGEMS. And then, again, based on a request, we'll just have a very quick look at Hammer and what it can do and how it's slightly different. Okay, so in terms of WaterGEMS, it's a comprehensive hydraulic modeling tool with a specific module for fire flow analysis, which we'll have a look at. The design we're going to do is using genetic algorithms in a tool called Darwin Designer, and you'll see the way that the genetic algorithm actually looks. And then the simulator, as I said, SewerGEMS. It's named SewerGEMS, which is slightly misleading. So SewerGEMS, in fact, has all sewer and storm functionality within one product. It's just that it was originally named SewerGEMS, and the name hasn't been changed to reflect the storm part of it. So it's got the same interface and tools as WaterGEMS. Again, the automated design. And I'll get through a little bit of the flexibility that SewerGEMS offers in terms of the engines, the runoff methods, and so on. Okay, and then the Hammer transient modeling tool. So you'll see that it has the same file format and interface as WaterGEMS, and some dedicated transient results viewers and tools within Hammer. So what I'll do is I'll go ahead and open up WaterGEMS here for a start. Nick, someone's got some problems with some audio there. For anyone, you might want to type in there to check their audio device settings in the tools menu there. Anyway, I'll continue. Okay, so this is an example here of an extended period simulation within WaterGEMS, and you can see over on the left here I've got the scenarios module docked, and you'll see I've got a tank control scenario, a constant speed pump, and then a variable speed pump. And so what I can do is, firstly, I'll run this tank control scenario, and so I'll get a calculation summary here. So the scenarios on the left are basically the way that you modify and then rerun models in a similar way to a save as. So the save as flow from base, you take a tank control scenario like a save as or a copy. The difference being that it's live the whole time. So if I were to make a change to the base now, maybe updating diameters or updating elevations, something like that, those changes would feed down into the scenarios below that, so that you don't have to make changes throughout your whole project or different scenarios. It'll filter down. So what I'll do is I'll turn on some color coding here, and using the time browser, I'll just play through and see what happens here. So with the tank control, you can see the tank over here on the right filling and emptying as this pump 4 turns on and off. So a pretty simple example here. I've got some demands down the bottom here with a pump, tank filling and emptying, a little control set here. So pretty simple example, but it'll give you an idea of what we can do with scenarios. So firstly, if I were to grab a couple of these junctions, I can go ahead and graph those for hydraulic grade, for example, and you'll see that for this scenario now, I've got 3 different junction pressures on the same graph, and you'll see in a minute why that's significant. So the constant speed pump, I'll now run that. You'll see that the tank is now grayed out. So the tank's turned off, and we've just got the pump on the whole time. So again, I'll grab the same 3 junctions and graph those, and we'll get a different graph. Yeah. So this one is changing based on the demand rather than the tank filling emptying. And then the third one, I'll change that over and give that a run. And this time, instead of grabbing those junctions, what I'm going to do is just grab junction 1 here and graph that. And now you start to see the advantage of the scenario. So over on the left here, I'm going to grab the tank control, the constant speed, and the variable speed pump, and I'm going to put them all on the same graph. So now effectively what I've got is 3 different copies of the model, or 3 different versions of the model, with a constant speed, a variable speed, and a tank. And what I can do is throw those all on the same graph at the same time there to have a look at the hydraulic grades and any other property that you wanted as well, you know, whether it's flow or whatever. So what you might want to do after you've made different scenarios is have a look at the costing of those scenarios. So if I go to the scenario energy cost here, and I'll start with the tank control, for example, you'll see that the tank is costing me about $690 a day to run the pumps in that manner. If I change it to the constant speed, you're looking at significantly more expensive for the pump being on the entire time, which you'd expect. And then the variable speed, you'll see that it's still more expensive than the tank control, only by about $40 or so per day. So the variable speed has obviously cut down that cost significantly. So these are the types of things that you can do with that scenario manager there. You'll also notice if I open up the tools menu here, you'll see things like Model Builder, T-Rex, SCADA Connect, Load Builder, Scenario Comparison, and so on. So what I'm going to do is flick it over to SewerGEMS now, and then what you'll see here is if I open up the tools menu, there's Load Builder, Model Builder, T-Rex, SCADA Connect, and so on. So basically the interface is as similar as it could possibly be, with all the tools basically the same. So the only difference between SewerGEMS and WaterGEMS is the differences that it has to have. So obviously manholes instead of junctions, and outflows instead of reservoirs, and so on. So got a question from Dennis. Okay, I'll let Nick handle that one a little bit later. So I guess the advantage of having the same interface there is you don't need to relearn it or learn different products. It's just a matter of learning one and then getting to know the slight differences between the two, just in terms of the different elements and sewer versus water. So what I'll do here is have a look at my scenarios again, and I've got a dry day and then a stormy day. So I'm going to make dry day the current scenario, and you'll see that what happened there is my catchments are now grayed out, and I'll go ahead and run that. So with no catchments, if I have a look at the manhole here, for example, I'll see that in the sanitary loads, I have a sanitary load entering here, so a house connection basically, and then there's also an inflow wet collection. So this is if you wanted to put infiltration in or something like that. But in this case, we've got nothing coming in from the catchments since they're turned off. So what I'm going to do again using the graphing is grab these three pipes here. So you can see I've got a diversion pipe down here, which is conduit 6, and then another conduit 3 here out to the wastewater treatment plant. So if I were to grab those and graph those, you see that I've got two on top of each other. So conduit 3 and conduit 2 have exactly the same flow, and the green one down the bottom here is 0 the whole time. So that's my dry day flow through that overflow diversion pipe. So at the moment, during a dry day with just the house sanitary loads coming through, we don't have any overflow. So what you might want to do is put a storm in there. So I'll turn my catchments on and apply a storm. So just to give you a look at the storm before I run this, if I have a look at the storm data here, see I've got a big storm. So at about 12 hours, we're going to get quite a bit of rainfall, pretty short duration storm, but we should see that's going to have an impact at about the 12-hour mark here. You'll also notice up on the top left all the different types of storms that you can put in, so time depth, time intensity, and all the IDF tables and so on, as well as rainfall. So pretty much however you get the information, you should be able to find a way to get it in. Okay, so I'll go ahead and run that one now. And what I'll do firstly is have a look at my catchment. So I can just right click on that and say graph and have a look at the flow out. And you'll notice there, question from Dennis. Where is the rainfall data coming from? Yep, so pretty much you can either enter storms from the library. So we do have storms available in the engineering library with the product. Alternatively, if you wanted real storms, you'd need to go to the Bureau of Meteorology website, grab that data for wherever's closest to you, typically in a rain file, and then import that. Alternatively, a lot of water authorities will have rain gauges and so on out near their treatment plants, and they'll use that data. So pretty much any way you want to put it in there, whether you've got the data directly from the BOM, whether it's yours or rain gauges that you've got yourself. Either way, there's certainly a way to get it in there, and that's the flexibility of having 6 or 8 different methods. So this catchment here, you can see, as you'd expect, so is this sewer with infiltration? No. I'll just show you this catchment here. You'll see that catchment's got this dotted line into the manhole. So what we're doing is directly, I guess, purposely putting it into the manhole. Infiltration's a different thing. So what you may have, if I open up the manhole here, you might have a sanitary load. So that's representing a house connection or several house connections. Then the inflow wet collection here may be your infiltration. And then you may have storm sewer drains that are collecting from this catchment and purposely entering that into the system. So 3 different ways there. Now, as well as that, you can also infiltrate into conduits. So if I wanted to grab a conduit, I can add an infiltration method to that and directly add flow into conduits as well. So there's a few different ways to add flow into the sewer storm network. I hope that helped, Dennis. Okay, so I'm gonna grab my three pipes here again and graph them again to see what effect the storm had on my flow this time. And you'll see that this time my conduit 6 overflow, of course, has a flow through it based on that storm. So you'll see that conduit 3 here has the top knocked off it there, where the inflow into the whole system is the red one there. So the green overflow has taken the bulk of that storm. Just on the catchments here in the method, if I open up the catchment and go to the runoff method area, we've got the runoff method here as a unit hydrograph. Now if I go to the drop down, you'll see that we've got about 6 or 7 different runoff methods. So basically you can select your own method, and that's based on the engine. So I'm using the implicit engine, and these are the runoffs available with that particular engine. So really it gives you the flexibility to use whatever method you want. And then if I have a look at the calculation options here, you'll notice that I've got 4 different engines here as well. So what you can do is pick your engine, pick the solver that you want to use, and then as you change the engine, the properties and the options available will update. So I guess the first thing is pick your engine, and then pick your runoff method, so that it's really very flexible in allowing you to use whatever you're comfortable with, or whatever your client wants to specify, or whatever your corporate decision is. Okay, so I've got a couple of questions here. We don't have combined flows in Australia. We have stormwater systems and separate systems. Yep. So that's no problem, Dennis. You don't have to use all of the all of the functions within SewerGEMS. This is a global product. If you're just doing sewer, then you can certainly use it for that. Or if you're just doing stormwater at a council or whatever, then you can certainly just use it for that. But most of our users around Australia are applying storms to their sewer networks and monitoring that infiltration. I've tried many times to adjust software and fit with meeting, but not quite sure what that one's referring to. I have to clarify that question a little bit. Okay, so what we'll do now is go back to WaterGEMS, and what I'm going to do now is have a look at an automated design example using Darwin Designer. So I've got a real-world system here, and what I'll do is I'll turn these background layers off so we can see it a bit more clearly. And what we've got down the bottom right here is a new airport terminal. And so what we need to do is design the pipes along the way to this airport terminal. So if I zoom in up the top here, you'll see that I've got a reservoir through a large red pipe into a treatment plant. From there, the rest of them haven't been designed. So I've got the larger pipes for my treatment plant. From there, I need to design down, so I'll turn that one off as well. So if I have a look quickly at my flex tables, at a pipe table, for example, you'll see that other than the three top ones here, which are my dirty water treatment, all the rest have just been set to a nominal diameter of 300. Dennis, is this for a sewer or water supply? So this first one, Dennis, is the water, and then I'll do a sewer example in a second. Yeah, so 600 mil diameters for all these for the dirty water, and then all the rest have just been set to 300. So what's happened here is that someone's drawn or laid this out in a GIS, and then they've sent it over to WaterGEMS to be designed. So they haven't designed anything in the GIS, all they've done is lay it out. So if I were to run that now, for example, you're going to get a whole host of problems with this system. What is dirty water? Just dirty water before the treatment plant. So that very small red pipe there is just from the dam into the treatment plant, and then the treatment plant out is that blue pipe at the moment. So it's basically just an intake pipe directly from the reservoir or the dam there. Dennis. Okay, so the first thing you notice here is I've got a whole host of negative pressures, and you also see I've got a little red exclamation mark here in my alerts and alarms tab. So if I double click on that alarm, you'll see that for these airport junctions 1 and 2, I would have a value of about negative 30 meters, but I'm looking for a pressure of greater than 20 meters. So clearly this system is not meeting my requirements. I want a residual pressure there of above 20. At the moment I've got it at about negative 30, so clearly it needs to be redesigned. And in fact, if I have a look at my junction table here, I'll just resize this window, you'll see that in my pressure column here, pretty much all my pressures throughout my system are negative, so not a very good system at this stage. So to redesign it, I can go to my design tool here, Darwin Designer. Okay, so the first thing in Darwin Designer is the pressure constraint. So this is what it's going to use to design the pipes. So you can see that for my airport junctions, as I mentioned, I want a residual pressure there of 20 meters at a minimum. And then I've got some various other T intersections and so on where I want minimum pressures as well. The design groups tab here is pretty important because each pipe within a group is going to be designed exactly the same. So each pipe within the same group is going to have the same diameter. So if I just minimize this for a second and have a look at my pipe groups, here you can see the 5 different pipe groups. So the very long green trunk main here, and then the off-take pipe, a smaller subdivision, and then 2 pipes out here to the airport. So those are my 5 different groups. Okay, so in the cost properties here, if I have a look at the highway pipe, you'll see this is the table that it's going to use to design. So I've got my material, the list of acceptable diameters to design with. Darwin Designer, is that where the project is from, Darwin? No, this isn't from Darwin. Darwin is just the name given to 3 of our modules: Darwin Scheduler, Darwin Designer, and Darwin Calibrator. And I think it's based on the fact that each of those Darwin modules uses genetic algorithms as its basis. So I think that's why they're named Darwin. It has nothing to do with the city, although I thought the same thing when I first heard it. So as I said, the properties here in this table are what it's going to design using. So it can grab any of these diameters with the associated cost. And then we've got an airport one here as well, where the costs are slightly lower, given that it's not on How Cool Evolution. Absolutely. Very cool. And hopefully in a second when I run it, you'll think it's cool. So the airport, slightly cheaper than the highway, just given the construction costs associated with the highway. And then the design type, and this is quite important. So at the moment, I'm minimizing cost. I've also got maximized benefit. So in this case, that would be a pressure benefit. And then there's a multi-objective trade-off where it'll give you the best option that's lower in cost with the best pressure benefit. So if I go over to my new optimized design run here and have a look at the options, and what I'll do is I'll give that a run. See that it's going to go through thousands of trials here, 100,000 in this case, until it finds the optimum solution. And then if I go to the Solutions tab, it'll give me the top 5 solutions in order of cheapest, basically, so because I had that minimized cost. And you'll see that the cost here, and if I go to click on the actual solution, it'll show me here exactly what it's done. So the highway group here, you'll see that they've all got the same diameter, and then each pipe's got an associated cost, and then each different group has its own different diameter. And the nice thing here is it doesn't just spit out a solution here with diameters. It actually simulates the results for me if I was to use that particular solution. So you can see it gives me a simulated pressure here, and especially for these airport ones, that I need to know that it's above 20. So it actually shows me what the pressure would be. So once I've reviewed solution 1 here, maybe I decide that I'm happy with it. In this case I am. What I can do is export this solution. I'm going to export it just like that, and if you have a look over in the scenarios here, when I click OK, you should see a new one appear. So now what I can do is, as soon as I make current that new scenario, you'll see immediately my color coding has changed with diameter. Does the cost include full supply and install, or is it a pipe unit rate? No, so that's why it's in units per meter. Dollars per meter. So it's designed to fully include the pipe cost with installation. And not sure where you're from, Dennis, whether it's a water authority or something else, but most water authorities in Australia, I've found, do have pretty accurate costs in terms of dollars per meter per diameter from their installation crew, with the pipe costs being pretty easy to factor into that. So it is something that I have found that users generally do know that dollars per meter figure. So you can see it's resized my diameters for me here, and now of course I want to test it, so I'm going to go ahead and run it, and you'll notice that I don't have any alerts or alarms or negative pressures pop up. And what I can do, of course, is check my pressures in my table here. So here we go, and I might just sort this column, ascending, and there's my 2 airport junctions, and you can see that they do in fact have a pressure above 20. How does the background, topography, and ground get taken into account? Yeah, so it's taking all of the elevation data and everything into account. It's got full contours in this model. I think I did have the contours as a background there. I've got rid of that, unfortunately. But it's certainly going to take elevation into account when it runs the optimization. All right, so basically I've checked my junctions and pipes and everything, and that's worked. So now what I might do is go back to SewerGEMS again, and this time I'm gonna run a design on a sewer system, and this one runs a little bit differently.
The connections adapted to.
Question from Andrew. Does Darwin consider options with without PRV or other treatments? No, it doesn't. It doesn't make recommendations in terms of to put a PRV in or not put a PRV in. Nor does it tell you what set point to make a PRV. But if you've got a PRV in the system, you can still design, either side of that PRV. So it will design with a PRV in the system. It doesn't make recommendations as to where or if to put PRVs or set points. I hope that answered your question, Andrew. Okay, so as I said, the automated design here in the sewer side of it, and this is a sewer example, but it could just as easily be a storm example and have inlets here instead of manholes that are being designed. But in this case, I just chose sewer. So firstly, what I do is open up my conduit table, and you'll see that all of my conduits, all my pipes, have a size of 100 mil. So that's just the base size. So those haven't been designed. That's just the minimum size. And if I have a look at my manhole table, you see that I've got a ground elevation here. What I don't have though is an invert elevation. So again, they haven't been designed. What I'll do is open up the profile, and you'll see that I've got a profile that's basically nothing at the moment. So there's no inverts, there's no profile. So clearly this system needs to be designed. So the way it's going to design is two things. Firstly, all the default design constraints that we enter, and then secondly, for the conduits, it's going to use the available design conduits from the catalog. So in the components menu, you see we've got an inlet catalog, a gutter catalog, and a conduit catalog. So in this case, using the conduit catalog, and the catalogs are pretty comprehensive. But if you had different options, different pipes that weren't in there possibly, or different sizes that you wanted to add, you can certainly modify these libraries very quickly and easily, and in fact import your own or create your own. So you'll see what I've got here is circular PVC available for design, but 100 and 150 mil are too small for me, so I've unticked those, so they're no longer available. To show you the library, if I import from library here and have a look, you'll see that I've got circular, different ones, aluminium, concrete, PVC, steel, and so on. Different box culverts, you can design culverts, channels, whatever it might be, and they're all listed there, as well as the ones that you may want to add yourself. So in this case, we've just ticked the circular PVC and added in this table here with all of the additional information, like the roughness factor and so on. So that's where it's going to grab the pipes to design from, and then the way that it's actually going to design is based on these default design constraints. So you'll see here I've got a velocity minimum and maximum that it's going to design between. Same thing with cover, a minimum and maximum, and the same thing with the slope, the minimum and maximum. You can see I've got extended designs over here, so I can change the number of barrels, so side by side. Dennis, aluminium. Where would aluminium be used? I've no idea. In fact, there's some pipes in the WaterGEMS library. I think there's glass pipes in the WaterGEMS library. I'm not sure who's using glass pipes, but they're in there. So choose to use them or not. Anyway, so there's also the node options here for designing inlets, nodes, and so on. So these are the types of things that you can change based on based on whatever your minimum maximums are, or the client, or whoever it is, whoever's coming up with the policy. So now when I go ahead and click compute, I'm going to run through that, design it all for me. And if I check my conduit table again, I should see that my size is now changed. So you'll see that it's designed them all to 200 mil, which you'll notice was the minimum size available for design. Go to my manhole table here. See that I've now got invert elevations.
Did we get to design that again? I missed some part here. Yeah. I think I was laughing a bit.
I can't quite hear whoever. I'm not sure if that was a question or just some chatter. Anyway, if you've got a question, feel free to jump in there. So inverts have now been designed. So what I can do now is have a look at my profile again, which should be now designed. And so now I've got a nice looking profile with my conduit size designed, as well as velocity, slope, and so on. So the Darwin designer there, using the genetic algorithms, running through thousands of trials to get to the optimum solution. This one here, grabbing things out of a library, either just straight from what's shipped with the product, or things you've added yourself, and you can have more than one available. So it doesn't have to be just PVC or just concrete or whatever. You can add several in there and let it choose itself. And these manholes here have been designed, obviously. It would be exactly the same if they were inlets, for example. So it's no different. Put inlets in there, catch basins in instead of manholes. The system will go through and design those. All right, so the next thing was there's a request to have a look at a fire flow within WaterGEMS. So I'll go back to WaterGEMS again and have a look at the automated fire flow here. So let me just tick that off. And fire flow, very simple to set up. I think a question here. What are the red and blue lines representing? Oh, okay. So in the profile here, the blue line there is the hydraulic grade, and then the red line is the energy grade line. So I can put the legend on there. So red there, energy, and the blue line there is the hydraulic grade line. Now this one here is just running it over one time step. If you ran it over an extended period, say 24 hours, what you could do is use the play button here, and you would see the hydraulic and energy grade lines rising and falling over time. And then the red one there above is the maximum for the whole time, which in this case is exactly on top of it because it's only one time step. Okay, so the fire flow, very easy to set up and run. So all you need to do to set up and run a fire flow is go to the alternatives here and open up the fire flow alternative, set some options in here, and then the calculation options are set to fire flow, and then run it. So you can see here I've got a fire flow needed of 41 litres a second, and I've got some pressure constraints here of 130 kPa. So I'm also going to put some auxiliary outputs here. Now what you'll notice here is the fire flow nodes is just using a selection set, so just a selection of junctions. So another question from Dennis here. Can this also be used for building hydraulics? Yeah, so I'm not quite sure what you mean there by building hydraulics specifically, Dennis, but we do have users that are using WaterGEMS and SewerGEMS specifically for factories, sprinkler systems, that kind of thing, just internal plumbing of buildings and so on. Maybe just let me know what you mean exactly by that. So as I say, enter your info into the fire flow here, and then it's as easy as that. Set up a scenario here, which, as you can see, I've already done with some fire flow calculations, and then go ahead and run that. So what you'll notice here yes, that is what I'm on about. Oh, excellent. Yeah. So we do in fact cater for that. We can put sprinkler systems in, and in fact, a lot of our users that are using WaterGEMS for internal plumbing and things for sprinkler systems are also using Darwin Designer to design those sprinkler systems because they're very fixed in terms of fire flow, in terms of what's required. So it's very easy to put those constraints in to Darwin Designer, and then get those fire pumps and boosters. Yeah, absolutely. So most of our users for those fire systems use Darwin Designer to size those fire flow pipes and pumps. So in the flex tables here, I can open up the fire flow node table, and you'll notice I've got a lot of not applicables here. And that's because we didn't run the fire flow on the entire system. We just ran the fire flow particularly on these. I don't know, about 20 nodes. So see here, I've got a fire flow total available. So it's showing me exactly what I can get out of each fire flow node compared to the fire flow it's asking for 41, and you'll see that they've all met that. And then the residual pressure here as well. And you'll see that some of them are very close, like this one here's only got 130.5 of residual pressure with my set point there of 130. So any lower and it may have failed. So if I have a look now, again, analysis menu and the Fireflow results browser, here you'll see they've all passed. So any lower and we would have had some failures. But what I can do now with the Fireflow results browser open is open up my junction table. And when I click on a different junction, and I'll just sort this descending, you see that when I click through, my flex table is now updating with different pressures, and these are the pressures that have been affected by that particular Fireflow node. So what it's done is, for the first one, it's gone, added 41 litres a second to junction 115 and run the entire model. And then it's gone to a junction 117, added 41 litres a second to that individually, and then run the model. So it runs the model each time, and each time it does that, it gets different results for different pipes and pressures and junctions that are directly affected by that fire flow. And we can have a look at that visually too by turning on the velocity. And you'll see, again, when I click through, different pipes are being affected by different fire flow nodes, of course, because they're all in different areas. So junction 115 up the top here is clearly different to some that aren't as far away. So specifically a Fireflow node table, Fireflow results browser, and you can click around and get some pretty detailed results out of all of the standard flex tables, as well as the specific Fireflow node table. So it's a pretty handy tool and pretty easy to set up. So the last thing that I wanted to show you is one of the newer features, and I've just changed it over to a virtual machine here, and the reason for that is because I'm running an actual SCADA system on this machine. So if I have a look down here, you'll see I've got the KEP server here running. It's actually a live SCADA system running on this virtual machine. So the first thing I'll do is change it over to a real-time model, and I'll zoom in here on one of these pipes. So I've got pipe 6. Question from Dennis: do you superimpose the layout on topography, and how? Actually, I might get to that question a little bit later, Dennis, because I've got a little bit of an example there, and just talk about some of the integration and stuff. So I'll get to that one in the end. So what I can do here is have a look and refresh my symbology here, and you'll see that this real-time flow now, as I update it, that flow's changing, and so that's representing an actual flow meter out in the field somewhere. It's on pipe 6 out in the field, and it's showing me within WaterGEMS what the actual value is right now out in the field. So it just gives you a little indication of what your system is doing as you're in WaterGEMS modeling. So the other thing is the historical scenarios, and this is where the real power is. So up here on the reservoir, for example, and I'll just run this model. If I wanted to have a look at the flow through pipe 1 out of the reservoir, so my total flow, I can just, instead of graphing the pipe, I can just graph the actual SCADA element. If I go OK here, it's going to put on top of each other the modeled flow compared to the actual SCADA flow. So you'll see that at the start here, the pump was off, and then the pump turned on, and the model turned on at exactly the same time. So it was perfect. And then the pump was on, and the model was modeling the pump. But you'll see that in the model, the pump stayed on an extra 2 hours or so there. So the pump, clearly the off setting in the model is incorrect. So the on setting's correct, the off setting's incorrect. Wow, Dennis, yeah. Yeah. So that's something we need to fix up. But it gives you a pretty quick indication of how you're going model versus actual SCADA system. So that's the first little feature. But well, what we want to do now is have a look at actual data that's been brought in, then projected forward using the model to get results, and then see what that actually results in terms of what if scenarios out in your actual system. So if I open up SCADA Connect Simulator here, and I'll give that a run, and this is just running the model exactly as is. So nothing's changed, nothing going on. But what I can do is open up my time browser here, and I've also got open a little a SCADA HMI. So this is representing just a simple system in my case, but with an actual SCADA system, if you had one, the idea would be that you don't create your own. You would go to the SCADA guys and take a save as or a copy of their their overview interface, and then use that interface to then project the results into. So if I start the playthrough here, you'll notice that now my results from my SCADA Connect Simulator are playing through my SCADA interface here, and you'll see that pump 1's on, pump 1 turns off, my tank drains, pump 1 turns back on, tank fills. You'll notice pump 2 is off the whole time for this simulation. And there's no problems, the tank doesn't drain, tank doesn't overfill, everything's good for this particular scenario. Okay, so the second scenario that I want to have a look at is what if I need some more flow? So I'm going to put some demand adjustments in here. And if I have a look at one of these demand adjustments, very simple. It's just take all the demands and multiply them by 1.8. So basically, we're saying, well, what happens to this system if I increase the demand because it's a public holiday or whatever, or something, or it's a hot day? And so now, with those demand adjustments, I can go ahead and run that again. And then play it through again. And this time, you see the tank drains, pump 1 turns on, The tank continues to drain, and then pump 2 comes on this time. Any water quality capability of this software? Okay, this is good. We're getting quite a few questions. Okay, any water quality capability? Absolutely. If we've got time, I'll very quickly show you what you can do with that, Dennis. Anyone using SCADA Connect with Smart Water? Yes, there is, Matt. Good question. So, some guys up in Queensland are trialling it. The problem being, no one that I'm aware of in Australia has an entire area that's got smart meters. So they're using smart meters in a certain small area, but their model as a whole does not have the entire thing using smart meters. So they are using that, but not for an entire model. But certainly SCADA Connect, that would be the perfect scenario for SCADA Connect, to have exact metered data brought in, added in, and then projected. So that would be the ultimate for sure. Okay, so that time again no problems because pump 2 came on and helped out there. But now what I want to do for the last one here is add a control override. So the control override, and again pretty simple. It's just pump 2, pump status is off from midnight for the whole time. So basically what we're saying is, okay, if we've got this hot day or the public holiday, whatever it is, and I need to take this pump out of service or this pump malfunctions, well then what happens? I'll run that one, and again play it through, and again something similar happens. The tank drains. You see that pump 1 is on, and then the tank drains a little bit more and a little bit more. This time pump 2 does not come on, and now we've emptied out our tank. So you can see that on our SCADA, we're clearly seeing that we've got a pretty serious problem. Got to go now. So well, happy birthday, Dennis, and thanks for coming. And if you want to see anything in terms of water quality or the other stuff, I'll probably get in contact with Nick. But go and celebrate your birthday. Okay, so you'll see that now I've got a serious problem here. So basically, that's a little intro into SCADA Connect, and we've got about 5 minutes left. So again, somebody has requested just a little look at Hammer. So this will only take a minute or two. So Hammer, again, exactly the same interface, and you'll notice that the Hammer example file here I've got is a WTG file, and the WaterGEMS files are also WTG. So there's no import or export. It's just simply open up the file within Hammer. And this time when I run it, you'll see that it runs slightly differently. So this time it's running a transient engine. It's a bit longer to run, but with significantly more detail. So we also have...
yes, it is. Yeah, well thanks, how are you?
Mark, with Waterhammer, can you model a valve starting as closed?
No, I'm just watching the Bentley webinar that's on at the moment, but yeah, no, it's alright, so everything's pretty on that thing. Yeah, that's alright, they're finishing up, so that's fine.
Okay, so I'll get to that question in a second there, Mark, but what I'll do firstly is have a look at the results here. So
okay, yeah. I think we're still very interested in upgrading to the WaterGEMS so that we can connect our SCADA information to our model, and I did get to do that with the trial, but unfortunately that...
I think I muted him, Nick. I think I did it myself. Okay, sorry about that. So the results here. First thing I can do is view a profile. So and I'll just open this out a bit. And what you've got here is a red line being the maximum. The black line is going to move in a second. That's my hydraulic grade, and then the green one is the actual pipeline, and the blue one being my minimum pressure. So when I play this, what you're going to see is nothing's going to happen for 5 seconds. So I got my pump on for 5 seconds, and at 5 seconds it's going to shut down. So when we reach that point, you'll see the hydraulic grade clearly drops, given that the pump's just turned off. And you'll see that it's down below the green line here, the pipeline elevation line. And as a result, see that up the top here, we're opening up a vapor pocket. So that's opened up, and now it's going to close down, and that's going to cause us to get a surge through. So here goes the surge. Did you mention what version you were using? Yep. So I'll show you which version I'm using of each software in a second, Andrew. Good question. So as you can see, we've got a pretty significant transient through this approximately 2 kilometre pipeline here, and eventually that settles out. So I'll finish that one there. The other thing I can do is have a look at a time history. So this is an actual pipe, and I can plot a pipe here and look at the flow and the pressure and the vapor volume within a specific pipe. So I can get that exact information per pipe if I want as well. And you can see the flow clearly drops off when the pump stops, and then it builds back up. We're actually starting the pump again there. So then I guess put some protection in. So I've got a hydro pneumatic tank up the top there, and then a surge tank down the bottom here. So we want to put in some transient protection devices and see if in fact that worked or not. So I'll have a look at my transient results viewer here again, and this time you'll see that it's going to be pretty boring. So I'll play it through again, but you can see straight away that my red line is nowhere near as high. The blue line here is not down below the pipeline pressure, so as a result, up the top there in the air vapor volume is 0 the whole time. In terms of what versions I'm using, Andrew, for WaterGEMS, it's Select Series 5. For SewerGEMS, let me check here. It's Select Series 4. 08, 11, 04, 54, so about halfway through last year. I'll just make sure of WaterGEMS here. Select Series 5, 05, 61, and that's come out 30th of January 15, so that's pretty recent. And then Hammer, and I'll stop that there. And you're looking at Select Series 5 with the same number and the same date as WaterGEMS. Okay, so in terms of modelling a valve starting as closed with 0 flow and opening it over a minute, absolutely. So what you would do there, and let me just very quickly open up a different example, which actually has a valve in it. Can you show forces on pipes? Absolutely. Yep. Let me just show you this this valve here first. So the valve here, in this case, is a throttle control valve going into a tank. Now, I know that you're talking about opening a valve rather than closing it, but exactly the same thing, but just in reverse. So if I have a look at this valve and the properties, you'll see that it's got an operating rule here. So if I edit the operating rule, this pattern is what's going to determine exactly what this valve does. So you can see that in 5 seconds here, I've got a starting relative closure, and then a time from start and a relative closure. So this one shuts in 5 seconds from 0 to 100%. So what you'd be getting, Mark, is the exact opposite to that. So your starting relative closure would be 100. And then you'd have a time from start here as 60 seconds, and then a relative closure of 0. So you have the exact opposite graph, and then what you do is just apply that pattern, like I've done here, and then and go from there. So you can also put different speed closures in. So you can see I've got a different speed closure pattern here. So you can put any pattern you like in. You don't have to have it linear like those other ones. So if you wanted to open that valve over a minute, you could open it 80% or 20% or whatever you wanted, and then show different different types of closures. So the different speed closure here is the ultimate one. The discharge coefficient is how to control the flow at what percentage it is opened. Yeah, you can. There's several different types of valves in here. So within Hammer, you've got the flow control valve, a throttle control valve, and a general purpose valve. Now, if you wanted a discharge coefficient, you can use general purpose valve. So based on which type of valve you choose, you can enter different information. So if you wanted a discharge coefficient, then you can certainly enter that as well. And again, in the patterns here, you'll see that we've got valve settings, valve relative closure, and then an operational as well. So the valve closure, the valve settings has a multiplier, whereas the valve relative closure has the time from start there. There's also different patterns within the valves themselves. So you can actually enter discharge coefficients and stuff in the properties of valves that aren't in the patterns here, depending on the type of valve that you choose. So certainly all the options that you're looking for will be in the software. It's just a matter of choosing the right valve and then applying the right settings to it. So I hope that answered your question, Mark. It's 59 past according to my clock, so that's all we had in the agenda, I think, unless I've missed something. So please, I don't have anywhere to be right now, so if anyone's got any questions, feel free to keep them coming. Otherwise, Nick, unless you wanted to say something, thanks very much for coming. Hit myself up or Nick with any further questions, or if you wanted to see anything else, please let me know. Pipe forces, yeah. So, sorry, Andrew, I forgot about that. So I'll go back to my hammer example here. So there's many different ways to get results out of hammer. So some of them are in report form, some of them are just results within the actual properties results here. So you can see all the different ones in here with the shear stress and so on, and then more results down here. So depending on what you're looking for, you may be looking at these transient results here. So continue any questions, attendees. Yep, no problem, Nick. But I suspect the force stuff that you're looking for is probably in the reports, Andrew. If you're looking for specific force type stuff, then you're probably looking at a transient analysis report here, and you'd find that sort of information in a transient analysis detailed report, rather than not all the results are available in the interface, because as you can imagine, there are millions of results available as you run it. So running that transient analysis detailed report takes a second, and so to be honest with you, it's not the easiest thing to read, but it will have that information in there for you. Forces of global. Yeah, that's something that the development guys have been looking at. I'm not sure how far along that is, to be honest with you. I'd have to check on that, but it's certainly something that the product manager's aware of, and they are working on that. And in fact, Select Series 4 to Select Series 5, a lot of the updates were to do with getting more results within the interface rather than in the reports. Now, you'll notice within the transient results viewer, you always had profiles and time histories. We've now also got the extended node data. So that's just some of the stuff. You know, the more results available in there now. As for the specifics of the pipe forces, I'd have to check, but I can get back to you on that. Okay, how valve settings pattern multiplier reflects the flow rate out of a valve. Okay, so what I might do is place down a couple of valves here. So I'll place down a flow control valve, a throttle control valve, and a general purpose valve. Now, if I open up the flow control valve firstly, you'll see that the way this is controlled here is an operating rule, and I'll change that to the valve operating rule 1. So, for some reason, there's very large values in here, but the flow control valve, the one that I'm in now, under the results tab, the flow is 0 for when I model a throttle control valve with starting closure at 100%. Yep. Yeah, so what you'll need to do, Mark, in that case, is most likely change some of your steady state properties. So you're going to need to run a steady state that's slightly different to what you used to, and then that steady state is the starting point for your transient analysis. So it sounds like you've used Hammer quite a bit. Have you played with the steady state on its own rather than running the transient on it to get around that? No, I haven't. Okay. Yeah, so that would be my first suggestion. So, as I say, there's the throttle control valve with the relative closure. Now, the second one here, the throttle control valve, here is where you can start to make some changes. So, you can change the operating rule, but you can also change the coefficient type. So, you can use a discharge coefficient, a head loss coefficient, or a valve characteristics curve. So that's what I was mentioning earlier about changing the type of valve you've got in the actual properties of the valve. And so let me just read what you said here, the valve settings pattern multiplier. So I think your question earlier was about discharge coefficient, I think. Yeah, discharge coefficient. So what you'd want to do is go into your throttle control valve here and change that from head loss coefficient into a discharge coefficient. And what that does is it changes your settings in your valve here. And so the coefficient type might be what you need to swap over, and then of course you still need to put in an operating rule for that discharge coefficient. But that's going to let you put in the exact discharge that you want for the closure. And then the same with the general purpose valve here. So this is an operating rule, just with a fixed operating rule here. Again, you can put the same rule on it, but it gives you this behavior type here as well, if that's something that you're looking for. So, Mark, just to clarify, Andrew was, Nick, I think you're recording this session. I'm not, but I can see that it is being recorded. Yeah. So, Mark, just quickly on your question there, the steady state that I'm referring to, what you may need to do is have flow going around that in an artificial manner, and I'll explain that in a bit more detail maybe offline or something. But what you'll need to do is have your steady state with flow through it, and then your transient with the valve closed, so that they're slightly different. I'm not sure if you're aware, but it actually runs a standard steady state before it runs any transient, and they don't necessarily have to be the same thing, but we can get into that at a different time, maybe with a one-on-one session, or I could have a look at your model. right, guys. Thanks very much, Andrew. I'm sure Nick will get in touch with you regarding the video. Mark, if you want to get in touch with myself or with Nick, and we can have a look at your model a bit more closely and see exactly what the problem is, see if we can get that sorted. Peter, no questions from you, but thanks for coming. Andrew, thanks, good session. Yeah, no problem. Thanks for coming, Andrew. No problem at all, Mark. And just let us know if I can help you out. Excellent. I'm sure Nick is eagerly awaiting by his desk and his phone.
Thanks, Dean. Thank you very much, and thanks, Andrew, Mark, and Peter, for staying a bit later. If you have any questions, please feel free to shoot me an email. So I'm the sales point of contact and also the account management. If you have any questions about the product itself, then obviously Dean is the best contact. If you haven't got his details, I'm more than happy to share it with you. Thanks again, guys, and have a good weekend.
Thanks, Nick. Thanks, guys.